Okay, so we got our next topic, which is problems dealing with right triangles. Okay, so for number one, we have five small circular holes are punched evenly on the rim of a circular plate with diameter of 20 centimeters. So find the distance between two adjacent holes. So this is what it looks like. So this is the figure. Okay, let me. It should look like something like this. So let's say that this is the. So we got five small circular holes are punched evenly on the rim of a circular plate with diameter of 20 centimeters. So this is the circular plate, and then we have here five small circular holes. So we'll be assuming that those five small circular holes are all have the same diameter or radius. Okay, so this is what it looks like. So we got here a circle here. This is the five small circular holes. Okay, another one. Nope. Okay. Okay, so this one, or you get the idea. Okay, or I think I can just make something like this and just copy that. Okay. There you go. So we will have here a circle here, and then another one here. Oops. Another one here. Then here. But it is something like this. Okay. It must be evenly distributed outside the circle. Okay. Now we are trying to find. Okay, I'll just complete the circle like this so you can see it clearly. Okay, and they should be connected, right? Connected. There you go. I think you get the idea. Okay, and then we are asked to find the distance between two adjacent holes. So we are asked to find um, this distance. Is this from here to here? Okay, so let's say that this is the center, right? Let's say this is the center. Okay, see? So if that is the center, we can connect a line here and then another line here. Okay, let's say that this one is L. Okay, L, or the L is the one that we are looking for. Okay, so let me just replicate it here so you guys can see it more, so I can make it bigger. Okay, so it looks like something like this. There you go. So this will be your center, right? This is our center as of now. If that is a center, therefore um, this line and this line are radius. Oops, are radius. But we all know there's a given for number one that the diameter is equal to 20 centimeter, right? Therefore, I can say that this is 10 centimeter and this is also 10 centimeter because they are both radius, right? These are radius and this is also radius. Okay, so we must have, since the topic for this one is right triangles, we must be able to make a right triangle here. So if you want to make a right triangle here, all you have to do is cut this one. If you make a line here, so this part of the triangle, okay, is a right triangle. Okay, this will become a right triangle. Okay, so from here to here, since all of this from here, this is L light, right? And then this one, of course, because it was cut in half, therefore this must be L over 2. Okay, so that will become L over 2. Okay, so how about the angle? How about the angle? So the angle for that one, again, let me just do the triangle again. Okay, I want to do it perfectly right now. Okay, so what will be this angle? So this theta. What is this theta? So you can see that the triangle, we can just the whole circle is a 360 angle, right? Therefore the theta will just be 360 over 5. Okay, so theta now is just 360 over 5, which is equal to, I think that's 72. So this is the theta. But if we, again, I will isolate the right triangle, you'll have something like this, right? So this is a right triangle. So this is the right triangle. Okay, this part. Okay, this is the part that I'm talking about. So I isolated it so that you guys can see it better. Therefore, this is still 10 centimeter, right? And then this part is L over 2. And then this is theta over 2, right? So this is um, theta over 2. Or this is simply theta over 2 is equal to what? 36? Is it? Yeah, that's 36. So all you have to do, so this is your right angle, right? This is your right angle, and just use what will be the relationship of that. Okay, so you'll have opposite over adjacent. So that is tangent. So tangent theta over 2 is equal to opposite, which is L over 2 over 10. Okay, so we can have here tangent. Theta over 2 is 36 equal to length over 2. So this will become 20. So we can have here length is just, or L, 20, tangent 36. So we think the answer for that is, yeah, I already got an answer here, is 11.7557 meters. So this will be our answer. Okay, so let's get to the next problem. Okay, so for our next problem, we have a transmitter with a height of 15 meters is located on top of a mountain which is 3 kilometers high. So what is the farthest distance on the surface of the earth that can seen from the top of the mountain, and take the radius of the earth to be 6,400. Okay, so radius, surface of the earth. Okay, surface of the earth. Okay, let's say that this is the earth. Okay, let me make it quite big so you can see it. Make it bigger. There you go. Okay, so if this is the center, okay, this is the center, and let's say that, okay, let's say that you this is the radius, right? So this will be your radius, and let's say that you have to add, here will be the what do you call that, transmitter and the mountain. Okay, so let's the so this part will be the, let's say that this height is h, of course this part is r. Okay, so this part will be the transmitter plus the mountain. Okay, so if I will now um, make a line here, so if you imagine yourself to be here, you're asking what is the farthest distance, okay, on the surface of the earth that can be seen from the top of the mountain. So if you imagine yourself here, you'll be looking at straight, right? Straight. So therefore, you can have a another line here. And then let me just extend this one. Okay, so it will look like something like this. So this will be your h and this is r. Therefore, this is also r. Okay. So you'll have here a triangle. Okay, and then we are looking for, let's say this is D. This is D. Now, dealing with that, of course, this will be a right triangle. So this will be a right triangle. So this will be a right angle. So if we want to compute, let's first compute for H. Okay, for H. So H will be 15 meters. No, it should be in kilometers. So 15 meters over 1,000 to make it in kilometers plus 3. 3 kilometers high for the mountain. Okay? So this will be your H. This is 3.015. Is that right? Yeah. So this will be 3.015 kilometers. Okay? So this is simple. Just use a Pythagorean theorem. Okay? So if you want using Pythagorean theorem, the hypotenuse will be h plus r, right? So your hypotenuse is h plus r squared equal to d squared plus r squared. Okay? So if we want to find d, so all you have to do is this will become h plus r squared minus 6,000 minus r squared. Okay? To find that, no, I forgot the square root. Square root. So just substitute all the values that we have. We will have here 3.015 plus your r. What's your r? Oh, r is 6,400 given. That's the radius of the earth. 6,400 squared minus 6,400 squared. So this will be the farthest distance that you can see from the top of the mountain. So d must be equal to, I think I already got an answer here. That's 196.4716 kilometers. So this will be your answer. Okay, so with that, let's go to the next problem. Okay, so for number 3, we have an air balloon situated 150-meter horizontally from an observer, flies vertically upward with constant velocity. After 1 minute, its angle of elevation is 28 minutes and 59 seconds. What will be its angle of elevation after 3 minutes from the initial position? Okay, so we have to draw the figure first. Okay, so we have this one. So an air balloon is situated 150 horizontally from an observer. Okay, so we got an observer here. So let's just draw a stickman here. Okay, and this is 150 meters. If that's 150 meters, therefore we have here a balloon, right? So this will become our balloon. Okay, so we get a balloon which is flies vertically upward with constant velocity. Okay, so it flies here with constant velocity. So constant velocity. We get a constant velocity. After 1 minute, its angle of elevation is 28 minutes and 59 seconds. Okay, so therefore, we can make a triangle here. So after 1 minute, the balloon will be somewhere maybe here. Okay, so let's say that the balloon may be something around here. Okay, so let's make a triangle for that. The triangle that we'll be making is, of course, we'll be neglecting the height of the observer. So it will look like, you can have this one, right? So you have a triangle here, ito, this one. So that is a triangle, right? So I'll be isolating that with another drawing. Okay, so this is the right triangle. Can I rotate this? Rotate it by 180. No. Flip horizontal. There you go. Okay, so of course this is still 150 meters, but we got an angle here. So what will be the angle? So after 1 minute, its angle, so at 1 minute, theta now will be equal to 28:59 seconds. So this will be your theta, right? And then we can get this x, or we can get h, right? Yeah, we can get that h. So solving for that h, so that will become tangent, right? That's opposite over adjacent. Tangent theta is equal to h over 150. So if we solve that, you'll get a value of h must be equal to, I think I already solved that. That is 83.0893 meters. Okay, so that simply says, because it is traveling in constant velocity, this will be the distance traveled after 1 minute. Okay, so this is after 1 minute. Therefore, we can have the same triangle. Okay, so we can have the same triangle. So of course, even how far the balloon is going, this is still 150, right? This is still 150. But now at 3 minutes, we are asked to find the angle of elevation. So we are asked to find theta, right? We are asked to find out theta. Or let's use a different one. How about beta? Okay. So we are asked to find beta now after 3 minutes. So at 3 minutes, h now, h is equal to 3 times the 83.0893. Okay. So this is equal to 249. Just call this, I'll be using a different variable. How about we call it x? Okay. So this is x, okay, and this is your h, right? 249.2679 meters. Okay, so again, that will be a tangent. So tangent beta is equal to opposite over adjacent, so that will become 249.2679 over 150. So just get the arctan of both sides, and then you'll get the value of beta, which is 58.9621. So this will be your final answer. Okay, so with that, let's go to the next and last problem for this topic. Okay, so we have our next problem. So we have, for our number 4. So for number 4, we have from the top of a lighthouse 53 above the water. So the angle of depression of a boat due south is 18 minutes and 50 degrees. So calculate the speed of the boat if after it moves due west, okay, for 2 minutes. The angle of depression is 14 minutes and 20 seconds. Okay, so we have, let's say that this is, so this is 3D actually. Um, let's say that this is the water. Okay, if that is the water, therefore we can have here straight line. Okay, so we have a straight line here, and that is 53 above the water. So therefore this is 53 meters, and at the same time this will be your lighthouse. This is the lighthouse, right? And then the angle of depression of a boat due south is 18 minutes and 50 50 seconds. Okay, so we'll have a boat due south. Okay, due south, so it must be somewhere south of the lighthouse. So let's say that it's somewhere here. Take note that this is 3D, so you cannot put it directly south. So if this is 3D, okay, so let's say that this is the boat. Okay, so this one will be your boat, and the angle of depression, okay, angle of depression is, so we can have a line here, right? So you'll have a line here, and then you'll have also the line for the lighthouse. Okay, and then the angle of depression for that, okay, angle of depression, so I have here some um, just some broken lines. So this is, let's say this is the angle of depression. Let's just call it, I need to make it thinner. Okay, let's make it beta. Okay, so that will be beta, and then we all know that beta is equal to what? 28 minutes and then 59 seconds. So what will be its angle elevation after 3 minutes? Sorry. No, it's not. Sorry. I'm looking at number 3. Should be number 4. Due south is 1850. Okay, sorry about that. It should be 1850. So calculate the speed of the boat after it moves due west for 2 minutes. So due west, it should be going west. So it should be going left, right? So this boat, from this position, you will have here this position. Okay, let's make it something like this. There you go. Okay, the angle of depression changes. Okay, so we can make another line here. So we can make another line here. Okay, this line will be connected. Okay, how do I connect this one? Okay, so this will become here. So it will be connected here, right? There you go. And then we'll have a different angle of depression here, right? So angle of depression of this one, let's just call this theta. So theta now will be equal to 14 degrees, 14 minutes and 20 seconds. Okay, So the time here is equal to 2 minutes, and this will become the new. So we are asked to calculate the speed. Okay, so for that we will assume that it is the velocity is constant, therefore we already have the time, and then all we have to do is just compute for the distance. Okay, compute for the distance. Let's say that we are computing for this one t. Okay, so this is a quite hard problem because it is 3D. So let's have, I will be assigning some letters on the vertices. So let's say that this point is A, and then this point is B. If you're assigning letters, it should be like this, D, and then let's say this is, yeah, so A, B, C, D. Okay, so from triangle ACB, okay, so from triangle ACB, um, triangle ACB, so you have something like this. So this is 53. Okay, and then we have here an angle of depression of beta, right? And that beta is also represent this one. This is also beta, that means. Okay, and then we can um, find the CB. Yeah, we can find the line CB. So this is line CB, right? This is line CB. So if you find the line CB, that will become tangent. Okay, tangent beta is equal to opposite over adjacent. So 53 over line CB. So if you compute for CB, we already have the value for beta, which is 18 minutes 50 seconds. The value that you will get is 155.39. So 155.39. Is this in? This is in meters. Okay. So this is in meters. Okay. Because what we want to do is, that's why we're computing for CB. If you connect this line, if you connect this line, okay, if you look at the triangle, that will be the ground, right? And if you connect the triangle BCD, okay, BCD, let me highlight for you this triangle, okay, that triangle BCD, we'll be using the triangle to solve for D, and then BCD is a right triangle, okay? Because as you can see, so A, the lighthouse, and then this one is directly south of the lighthouse. Therefore, that is a straight line. But we cannot, for the purpose of the drawing, because it is 3D, you cannot put it directly south. Okay, on the drawing only. But it is a straight line. Okay, so you can see that this and then this one is a, therefore this is a right angle. If you imagine it, really good. So we already have the value for CB. I think we can compute for the DB. Can we? Yeah, DB. We can compute for DB. I think. Okay. So continue. So we can have the triangle um, BAD. Okay. BAD. BAD. So this is 53, right? This is still 53. And this angle will be your theta. Okay, and then that theta is also, that means this is also theta, and this is line DB. So again, we can use tangent. So tangent theta is equal to, tangent theta is equal to adjacent over no, opposite over adjacent again. Oh, so that is 53 over TB. Okay, so we already have the value for theta, which is 1420. Okay, 14 minutes and 20 seconds. So the value for dB to solve for that is 207.42 minutes. 42, no, not minutes, meters. Okay, and then now we can use the triangle CBD, no? CBD. So using the triangle CBD, that is a right triangle also. Take note of that. So that will become, we already have, so this is CB, line CB, and then this is line DB, and then this is D. Okay. So now we can compute for D using simply the Pythagorean Theorem. So you'll have, let me change the color. D now will be equal to square root of the hypotenuse, dB squared minus CB squared. So value of D, I think I already computed that. So D, line DB is 207.42 and line CB is 155.39, these two. So you'll have the value of D, which is 68.7 meters. Okay. And then, since we already have the D, so we can get the formula, which is S equal to VT, right? That is the distance equal to the velocity times time, since we are looking for the velocity. Our S there will be the D, okay, or at least I can change it now. So D is equal to VT. We already got D, and we have 2 for the time. Time is equal to 2 minutes, right? So therefore, V is just equal to D over T, which is equal to 68.7 over 2. So the answer for velocity is, oh, you cannot see it on the camera because I was blocking it. Anyways, I think you already got the idea. So the value for D is simply equal, no, I think I got it wrong. This is not 68.7. This is, sorry about that, I got confused. So the value of this 137 actually 0.4. Okay, so this will become 137.4 over 2. So the final answer is 68.7 meter per second. Okay, so this will be your final answer. Actually, it's not D again. It's V. That's the velocity. Sorry about that again. So this is V. Okay. So I think that's quite a hard problem because the drawing is, the figure is a 3D figure. So with that, let's proceed to the next topic.